In this video, we'll talk about how to apply state space model into the differential equations that we have just derived in the previous video. And therefore, what we are going to cover now is in terms of this third term. Alright, previous video we talked about this two. Now, the third one. Alright, and therefore to apply the state space model, the first thing you need to do is to look out for the highest order of the variables. Alright, thetas are all the variables that is changing. Okay, so we're gonna look out for the highest order. Alright, and therefore if I were to know that this is the highest order, the next thing I'm gonna do is to write the equations in terms of this highest order, or in other words, I'm gonna move this 2 to this side. Alright, so theta double dot is equals to this one minus this 2. Alright, just simply moving this one over this side. Okay, if I were to do that, I would have this one over here. Okay, so the first step is to write the equation in terms of the highest order. The next step, alright, is to just define, is to find how many variables are there, alright, in this over the side, over the side. So in this case, I have two variables. Okay, I have two variables, and these variables are simply the xt. Okay, for now, if you don't understand anything, it's okay. I'll just write it down later on, you will get a full picture of it. So I'll just write down as xt, and perhaps I can label this as xt. Okay, and only applies for this first equation. Okay, only applies for this first equation. The values, the matrix of the xt, okay, if it's 2 times 1, will determine the end result over here to be 2 times 1 also, which in other words, x dot t has to be a 2 times 1 matrix. If it's 3 times 1, then this must be a 3 times 1. Okay, this is only applied for this case. Alright, and just a quick view to the modeling, to the block diagram, is that this is x, this is x dot. Okay, so they are somewhat correlated to each other. Okay, I'm not going to go into details, but this is it. And therefore for this first, the first equation, as I keep repeating itself, you can utilize this method. Okay, once you determine the xt, once you determine the xt, you can just simply write over here. Okay, therefore this is the third step, this is the fourth step. Okay, the fifth step now, okay, to fill in this matrix. Okay, and how do I fill in? You know that xt and x dot t, the difference is that xt, when you differentiate one time, you have x dot t. Okay, this is the meaning. And therefore what you have over here, if it's theta dot, if you differentiate one time, you can represent it as a theta double dot. If it's a theta, you can differentiate one time, and you can just put it over here. This is how it is. Okay, now the fifth step, I would say, the clearer fifth step, is to determine the A matrix. Alright, we know that this outcome must be 2 times 1. Okay, how do I ensure that it is 2 times 1? 2 times 1 over here. Alright, I must have a 2 times 2 matrix. Okay, I can have 1 times 2 also lah, but I just write as 2 times 2. For that reason, later on you will know what is the reason. And then plus b. Alright, in this case ut is simply te, which is this one. Okay, so in this case, this state space analysis is somewhat to describe, it's somewhat to describe the differential equation over here. Alright, by breaking down order by order. So first of all, I set this thing in terms of the highest order by filling all of this. Alright, when I fill in all of this, alright, theta e, which is over here right now, has a coefficient of 1 over I. This is not theta, I mean tau e, sorry, the torque itself. Okay, this is for only the first row. I didn't draw a proper line, which is the first row over here. This, it corresponds to this differential equation. Okay, this is what I'm trying to do now. Next, theta dot is expressed in terms of minus ci, c over I, right? Minus c over I. In fact, this is, I shouldn't have write that. I don't know what the hell I'm doing. Yeah, this is just simply minus c over I. Okay, and therefore, this is minus c over, minus c over I times this one. Okay, so this thing times this thing is equals to this thing. Alright, this is just matrices. Okay, and let me clear away the steps lah, because I think it kind of hinders us. Alright, okay, this is just better. So the steps that I've just deleted is just saying that the first step, what do we do, the next step, what should we do. Alright, so I think so far so good. I think once you set up this one, you should be safe. Alright, so I'm just trying to share with you how do I set up the equation. Alright, to continue, alright, since we know that minus ci times theta dot can be represented in terms of this one times this one. Okay, next, minus mgl over 2I times theta. Alright, so this one times this one is equals to this one. Alright, this is just simply the matrix matrix stuff. Okay, I have written over here. Okay, now how do I represent theta dot? Okay, theta dot in this case cannot be represented by theta double dot because I only have one equation. Okay, I only have this one equation, that's all. Okay, I do not have any other equations. Okay, and therefore I can just simply, alright, what do I mean is that, okay, for example, if I were to represent theta dot, this means that everything, okay, I have to bring this thing over to this side. Okay, I gotta make everything in terms of theta dot. Okay, while this theta dot, alright, this thing over here, if I were to make in terms of this thing over here, the variables are in terms of a higher order than this theta dot, which is impossible, right? Because in this xt, the highest order is itself. You get what I mean? And therefore, the highest order, if it's itself, then I can just simply rewrite itself as itself. So it's just theta dot with 1 times itself gives back itself. That's just its own thing lah, okay? And then 0 plus 0 tau, because theta dot is equals to theta dot. Okay, so in terms of matrix, you are just simply writing back 1 times this one is equals to this one, which is equals to this one. This one or this one. Okay, I think you just need to practice more and it should be fine. Okay, and you may wonder why I didn't write 2 times 1 over here. And why is it 2 times 1 over here? It's because since this is 2 times 1, the outcome is 2 times 1, then therefore this is also 2 times 1. Okay, this is just summing. Alright, so summing of matrices should be in terms of their same order. Alright, this whole thing is 2 times 1. So summing a matrix with a matrix must be in the same order. Okay, this is the rule. Alright, okay, so therefore we have cleared away only this part. Okay, we have cleared away this part right now. Now we're going to talk about this part over here. Alright, yt is the output. So what we want as the output is in fact theta itself. Often in yt, alright, or in other words in this second equation, this yt is often in terms of the last of the the xt itself, okay, or perhaps the last few of the xt. Okay, I'm not going to go into details because there is other examples, okay, but anyway, in our case, this is the only one, or in other words, our outcome is only in terms of theta, it's in terms of the angle of our leg. That's all. I just want to know the outcome, that's all. Okay, and therefore I can, since we know that theta is just a number, which is a 1 times 1, and therefore we know that xt, because this is in terms of xt also, correct? And you write theta dot and theta. Okay, I'm just keeping this thing the same as xt. Okay, so this is 2 times 1. So how do we achieve 1 times 1 matrix? And therefore we're going to introduce 1 times 2. So 1 row times 2 columns, okay, plus, alright, because we have a ut over here. Ut in our case is actually te, right? Same thing. Okay, so I'll just simply write te over here as ut. And this is the matrix over here is C, and this is the D. Okay, so this whole thing is just 1 times 1, and therefore this one is 1 times 1. Okay, and therefore this is just a number. Okay, theta itself similarly is also dependent on its own self. Alright, because theta, we have no other informations. Alright, theta is simply theta itself. Okay, and you cannot, theta cannot be represented by higher order of itself. Okay, please remember, anything cannot be represented by higher order of itself. This is why, as you can see in our theta dot example, we cannot represent this thing in terms of a higher order than him. Okay, hope that this is somewhat clear. I know that this is a bit weird. And therefore theta, if you want to represent theta as theta itself, you just write 0, 1, right? Because 1 times theta is equals to theta, and then this is simply 0. Alright, and this is yt, and therefore this thing is this one. Okay, and then this thing is simply the top one. So we have just written down the state space model, I would say. Okay, and therefore before I end this video is that A matrix in terms of 4 components over here, which in terms is describing this thing feedback. Okay, B matrix describe this thing. Okay, so each of this matrix contains information. It contains information on a certain stuff. While D itself is simply 0 in this case. Alright, so this is somewhat an application of a linear state space equation. Alright, take note that it's a continuous time invariant. Alright, and that is a state space model to analyze stability using the pendulum analysis. Alright, and a concept of top differential equation. I hope that this is pretty much helpful, and I shall see you in the next video.